Chapter 4.3 Day 1 Solving System of Linear Equations by Elimination. You try problem number 4. So equation number 1 is this one, 8x minus 7y equals 18. Question number 2 is negative 8x plus 2y equals 12. They both are opposite and same. So when you add the 8x and negative 8x cancel, you're going to get negative 5y equals 30. Divide with negative 5 on both sides, you get y equals negative 6. You found one of the variable, and to find the other variable, you're going to plug it in one of the original equation. So I'm going to use equation number 1. When I use y as negative 6, I got 8x plus 42 equals 18. Subtract 42 on both sides, you get 8x equals negative 24. While you divide 8 on both sides, x equals negative 3. For the checking part, you get equation number 1 and equation number 2 and plug it in x as negative 3, y as negative 6 and see if the two sides are equal. If the two sides are equal, it means this is your solution. Question number 5. So you have two equations, 6x minus y equals negative 15, equation number 1. Equation number 2 is 6x minus 5y equals negative 27. None of them are same or opposite, but these two, 6x and 6x, are same. All we need that one of them should have an opposite sign, so I'm multiplying negative 1 to the bottom equation. So what I got, the first equation as it is. The bottom equation, when we multiply, you get negative 6x plus 5y equals positive 27. Add them, you get 4y equals 12. Divided by 4, you get y equals 3. Plug this y equals 3 into one of the original equation. So I'm choosing equation number 1 and put here y as 3. 6x minus 3 equals negative 15. When you add 3 on both sides, 6x equals negative 12. Divide with 6, you get x equals negative 2. So your coordinate is negative 2 comma 3. Now you're going to check by choosing equation number 1 and equation number 2 and plugging in x as negative 2, y as 3. When I did that for both of the equation, I got the one side equal to the other side. One side equal to the other side means that negative 2 comma 3 is the solution of the linear equation, system of linear equations. Question number 6. You have two equations, equation number 1 and 2. In these two equations, you can see that the negative x and x are opposite and same. So when you add them together, you're going to cancel the x and negative x. You're going to get 12y equals 36. Divide 12 on both sides, you get y equals 3. Now you're going to find out the x value. To find the x value, you can choose any of the original equation. So I'm using equation number 2 and plugging it y value with the 5. So it's going to be x plus 5 times 3 equals 6. Subtract 15 on both sides, you get x equals negative 9. So the answer is negative 9 comma 3. For question number 7, you're going to see in two equations, equation number 1 and equation number 2. So now you're going to see what variable you can eliminate. And if you notice here, you can see that 13 and 13, they both are same and opposite in sign. So when we're going to add them, this y will be eliminated. So we're going to eliminate y. So what we're going to get is 5x equals 30. And when you divide with 5 on both sides, x equals 6. Use one of the original equation to plug it in x to find y. So using equation number 2. So So I'm using equation number 2 here. X minus 13y equals 19. So I'm plugging in x value as 6. So it's going to be 6 minus 13y equals 19. Negative 6 on both sides. Negative 13y equals 13. Divide with negative 13, you're going to get y equals negative 1. So writing it into a coordinate form, 6 comma negative 1 is your answer. For question number 8, I can see that the 6x and 6x are same, but these are not in opposite signs. So when we add them, we cannot cancel them. So we have to make one of the 6x as negative. In order to do that, we are going to multiply either the first equation or second equation by negative 1. So I'm multiplying the second equation by negative 1, which means the first equation remain as is, and the second equation will change its signs. So this is going to be negative 6x. Negative 1 times negative 8 is positive 8y, and is negative 16. Now when we add them, the 6x and negative 6 cancel. You're going to get 3y equals 21, and you're going to divide with 3 on both sides. The y is equal to 7. You found one of the variable, and to find x, use one of the original equations. So I'm using the original equation, that's the top equation, 6x minus 5y equals 37. So you get 6x minus 5 times 7 equals 37. 6x minus 35 equals 37. Add 35 on both sides. You're going to get 6x equals 72. Divide with 6 on both sides. You get x equals 12. So your answer is going to be 12 comma 7. Next question is number 9. And in number 9, I can see that the 3y and 3y are same in number, but they are not opposite. So we are going to multiply one of the equation by negative 1 so that we can have one of the 3y as negative. I'm rewriting the top equation as it is, and I'm multiplying the bottom equation by negative 1. So I'm going to get negative 4x minus 3y equals negative 11. When we add them, the 3y and negative 3y cancel. So you get x equals 8. Once you get the x value, you're going to use one of the original equation. And in this case, I'm using 5x plus 3y equals 19 to solve for y. So I'm plugging in x value 8 and solving it for y. So I got here is 40 plus 3y equals 19. Negative 40 on both sides, or subtract 40 on both sides, you get 3y equal to negative 21. Now subtract 3 on both sides, y is negative 7. So x is 8 and y is negative 7.